And yeah, I just got 2:30 on my for that.
I'm being recorded.
Well, I want to make sure. Yeah, I want to make sure that nobody misses any of this in case somebody wants to go back and listen to it.
Hey, Tom,
We'll do that. So.
time.
That's right. Yeah, Tom, can you check the clocks? Because I don't know if they have these synced up. No, that's not. I think I asked them about that when I was touring there, because I noticed that the times were off a little bit. I think that they're not all focused.
So he told us it was a really cool system that links all the clocks up in the building wirelessly using NTP.
Cool. See, that'd be the thing. I want that for my house.
They run on batteries. 4 years on the wire.
Cool.
Yeah, next time we replace clocks, I'm
Kinda like-
gonna give them the atomic clock soon.
Yeah.
Like
We don't get
radio
atomic.
waves.
We don't get atomic signal.
Oh, really?
You see, like there's a dead zone.
That might be good. Okay, so let's get started. So wait till I go to sleep here. My name is Albert Masters. I'm the Director of Internet Development for CALI, which, that's a fun title. It roughly translates to like everything web and database oriented stuff that we do. So it covers a lot of it. Oh, plus sysadmin. That's the other one. I mean, when I was in the LII XML thing the other day, and each one had their little 5-minute piece, and I was thinking, I do that, and they do that, they do that, they do that. Not on that scale, but I suppose we all could have done that, right? We all do a little bit of everything. So what I'm going to be talking about today is the move of CALI to the cloud, which is pretty much finished right now. There's a couple of things still running on servers, or on actual physical servers, but not a lot. What was it? Does anybody else have problems with Mac and mouse focus? Anyway. Yeah, Google that. A little bit about the sort of infrastructure that we have. CALI runs a whole mess of open source software. So we're running Linux and PHP and Drupal, MySQL and Apache. Primarily because, well, that's what I know. Second of all, it works well for us in that we sort of have limited budgets and stuff, and we can work with it. So everything I'm going to be talking about is actually open, like completely open source. But one of the key things about Amazon, which we're using, the Amazon Web Service, is you can actually run Windows there. I don't know if has anybody in the room tried that? Running Windows in the cloud?
Isn't it more expensive?
Well, yeah, it is, but it's still not. It is more expensive than running Linux in the cloud, but it's not hugely expensive. And actually, that's sort of has anybody done anything with running stuff in the cloud? Anybody doing anything with production? How about just testing stuff, trying it out? A little bit, yeah. I mean, it's great if you have access to a credit card, anyway. Because they won't bill you, and that's actually been a thing about how the whole thing works, right? Because there are a lot of places that there are major corporations that won't participate because Amazon won't invoice them once a month. They actually have to have a credit card, and they don't allow that sort of thing. All kinds of stuff, and that's actually impeded some universities also in terms of getting into the space. And actually, it runs on my personal credit card, and then I send, CALI cuts me a check. So, and some people do that if they have sympathetic bosses and whatnot. So that's sort of the background on what we're running. Now we we were running stuff on Dell servers. And our entire website ran on both the database and the web server was running on a single Dell server. Okay, and that had performance issues, especially on those days when we'd have 10 or 12, 14,000 students trying to run lessons. You know, it would slow to a crawl. And it had it pretty well optimized, but we were still having, you know, we still had kind of major issues in terms of what was, you know, what was happening, and it got to the point where, you know, we need to do something. And at first, I was going to build a physical cluster because that seemed like a good idea. But there were a couple of things about that, about building the physical cluster. It's expensive, but in the long term, probably not more expensive than running Amazon. It took, one of the big things, of course, was space, right? Because CALI's a virtual organization. And, you know, I have servers, I control servers at Emory and at Chicago Camp. And we sort of have space there. We don't have a lot of space there. I have some slots and racks. You know, if I showed up and said, look, I need to build a cluster, so I'm going to need, you know, a dozen slots or whatever, that, you know, to stash some servers in, both places would have said, no. We just don't have the physical space to do that sort of stuff. So that was, you know, that was kind of a problem, and I wasn't going to run it out of the house because Comcast would get all. But so that just wouldn't have worked. So what we really came up with, right, was the notion of running CALI in the cloud. So we went with you know, opted for Amazon Web Services as the sort of platform, and we actually were using, there's a whole mess of acronyms. I'm going to guarantee you now in case I start spitting them out later, so you can sort of, you know what's going on. There's Elastic Compute Cloud, which is EC2. Those are the actual server instances that Amazon runs. There's Elastic Load Balancing, which is ELB. That's the load balancer that distributes web traffic between the various server nodes. There's S3, which is the simple storage service, which we use for some file storage. And then there's EBS, which is electronic block storage, which is another way to store files, which we also use. Actually, we use more of that. So those are the acronyms. So we went to the cloud. So we were looking for scalability, right? Because we have really busy times of the year. We were looking for some sort of predictability, right? We knew that Amazon was always going to be there. It was stable, or at least they're going to be there as near as we can tell. Knock on, probably not real wood, but we haven't had any significant issues with them, and we certainly haven't lost any data, and everything's actually worked pretty well. There was one small caveat in the area of email, and I'll mention that briefly in a little bit. And then also there's the freedom thing of not being tied to a physical cluster someplace, which actually works well for us just because of the virtual nature of the organization. So we went to the cloud, and the first thing that I set up, the first thing I did was I put the database on a separate server, and then Drupal and Apache and PHP on a separate server, and that worked well. I mean, we pretty quickly saw performance get better, and that worked. That was just really good. Up until, right? Because there's always an up until it didn't work. which was which was sort of the thunderstorm part, right? We got to the part where exams kicked in for the first time, where the exam season, was coming upon us, and it happened the week before Thanksgiving this year, and immediately our traffic went through the roof, and there were huge performance problems. Okay, we were basically getting. We were just Apache wasn't performing right, and we were having issues with the database because Apache was making lots of requests to the database, and they weren't getting closed right, and the database had lots of open connections, and then the database had too many open connections, and Apache had too many open connections, and then we started serving up busy signals essentially, and so then that was just a really big problem. So that was sort of the thunderstorm. So I knew this was going to happen, by the way. But I was hoping to sort of get through, because being sort of the one-man, kind of IT shop, I had a lot of stuff going on, and I was hoping that I had I was actually planning to do the load balance part of this talk, the week after Thanksgiving, because I was going on vacation and stuff, and so the week after Thanksgiving would be good. I should be able to get it in just in time, but that didn't work. Okay, so we had to look at load balancing. Does anybody do load balancing in front of their websites at all? Yeah, it's really not. I mean, unless you actually have a ton of traffic, then a lot of stuff you don't really need it. 2 years ago we didn't need it. Now we need it just because our traffic's increased.
Just used, round robin DNS between two, and that gave us a decent start.
Right. Yep, that works. Right, that's some really basic stuff. I mean, I looked at things like round robin. Well, I knew we needed to go to load balancing because I needed it for performance, right? So the idea would be that everything goes to a single host, and then it gets sent out to a series of web servers that sit behind that host, right? So instead of having all the traffic go to one place, it gets divided up between X number of nodes behind it. So I knew that I wanted to do that, and I did. Come back to life. Because I have my notes on my iPad, and I keep notes. So I need to just remember to move it occasionally. And then the other thing about load balancing was that it gave you the opportunity to sort of be scalable, right? So I could have a load balance in the front end, and I could just add nodes behind it as we needed them, right? So when traffic got slow, I could essentially turn off servers. Another benefit of the cloud, right? And that was the thing with load balancing in the cloud, right? It was pretty easy with Amazon, with the ELB, with the elastic load balancing. It's basically kind of a turnkey black box solution. You say, give me a load balancer, and you point www.cali at it, and then on the other end you just attach web servers to it, as many as you like, and it distributes the traffic automatically. Okay, so I figured out how to do. I put all that together in like a day the first time through, and a heck of a day it was. Actually, it was about 2 days, because what was happening was, this is sort of the way that our traffic runs. Okay, we'll have the bottom graph was March of this year, and that's relatively typical of sort of our mid-semester traffic. We get about 3,500 visitors a day, and it's pretty common, right? Generally, generally that'll work. That works fine with a couple of nodes on the load balance. It's really not that bad. December, we get that peak of 20,000 visits. That's actually a little deceptive, because even though there's 20,000 unique visitors that day, they're actually doing about like 3 or 4 times as much on the site as the average visitor in like March. So in March, March a student will come to the site, do a lesson, and go out drinking, probably. Right? So, in December, they come to the site, they're getting ready for exams, they'll log on to the site at 8 o'clock in the morning, and they'll spend 5 hours doing lessons. They'll do a dozen lessons. They'll be there all day. The amount of traffic that generates tends to be pretty impressive. And so the load balancing, provided a way to sort of even all of that out.
So Elmer, have you averaged out how many lessons they see during that December traffic per student?
Yeah, we do it. I don't know what it is offhand, but yeah, we track the lesson usage in a table. Because like every time a student runs a lesson on the site, it enters a row in a table. So, and right now we do, like last year we did just over 1 million runs. I think this academic year will be about 1.1 million, something like that.
And can you base that on school?
Oh yeah. Oh yeah, we know when a student logs in, when a student registers on the website, they have to have one of those dreaded authorization codes. And everybody loves those, right? That was my invention. But the thing is, we need to know. Yeah, I know. It's not.
That's because you get the emails like me from the students saying about this fight. You put it on the website and the blog, and you give the cards during orientation.
Yeah, they don't know what it is. Well, the thing is that it's necessary for us because there's actually a couple of things. We need to know that they're law students. And that they're associated with a specific school, and then that way all that stuff is trackable. The other thing is that the lessons actually there are a handful of lessons that actually have material in them that's licensed, that we can only share with students, faculty, and staff of member schools. So we have to know who they are.
Can you just change that to the email address and make them use their university email?
Well, we could if some of them knew what their university email address is. I'm not exactly sure that that's actually a better solution. I mean, we're up to about 3/4 of them don't use .edu email addresses because they're allowed to use whatever email address they want. And there are a couple of schools that preload. They actually sit down a team of whoever and actually create accounts for their students, but they use the .edu addresses. And a lot of times I end up with as much as 1/3 of the class creating another account with their own email address because they forgot. I mean, so it's better that they forget what the authorization code is as opposed to forgetting that they already have an account. And I have people who register, at the beginning of every exam season. They create a new account just because they don't, there's all kinds of permutations of just fun and joy. But the thing is we track all that stuff, and it's all in the database. The lesson run table that has all that data in is like about 5.8 million records at this point for like the last 5 years. I think it's been running 4 years. So the database is really huge, by the way, which is another reason why we need to have a dedicated database server, because the database has gotten really big. There's a lot of stuff in it. We've got about 250,000 registered users. From over the years, and we probably have right now about 3/4 of the law students in the country. Current law students are registered. Like almost 4,000 faculty. I only know that number because we just sent them all email. So then I had to pull that list. So we get these little bits of variations in the way our traffic runs. So the load balance led to this. Yeah, boy, it was a lot simpler when it was that one box stuck in a rack someplace. I can tell you that. But what this is actually the current configuration that's running right now for the CALI website. Okay, so coming in from the network, you get to the load balancer first, And then that's going to divide the traffic up between any one of 3 nodes. And then those 3 nodes, they're all running just Apache, okay? And basically, I've built each server, because one of the pretty cool things about Amazon is the ability to sort of custom build the image, the virtual server image that you use. So I have sort of a standard one that has like a bunch of stuff preloaded on it. And I use that. That's based on CentOS Linux, which is the open source version of Red Hat Enterprise Linux. So it's built for this sort of stuff. But those, the load, well, let's start with the load balancer. The load balancer doesn't have any real controls on it. There's not a lot I can do with it. It basically is designed to just accept my traffic and spread it between those nodes. Amazon has added a couple of features lately, like the ability to sort of pass session information so that you can make sure that the client is always talking to the same node if you need to do that. I don't really need to do that. We handle that, gets handled through the database anyway. But that's one thing. There are other things that it can't do, one of which I'll mention is the ability to sort of route all the static traffic to a certain spot. I'll get to that more in a minute. So those 3 nodes in the middle are just running Apache, and they also have the Drupal code on them, okay? So, but they're not running MySQL, they're not running a lot of stuff, actually. I turned off a whole mess of things. Now, one of the things about Amazon that was a little painful about this was the way that it handles email, which is to say they really didn't want spammers in the cloud. So basically what they did was they gave all the blocks of IP addresses to the various spam filters and said, spam filter people, and said, none of these should be sending email. Which is nice, except for those of us that were actually, needing to send email. I mean, Drupal will send out a lot of email, right? And so we were running into big problems where, for a while, I couldn't send any email to Comcast customers. Now, Comcast is like the AOL of this century in terms of, when I started this job, well, it's only been 7 years. I mean, I came in at the end of sort of dial-up, but AOL was still half the traffic to our website at that time was through AOL dial-up numbers. And at one point, 80%, 85% of our web traffic was through AOL dial-up. Now that's sort of switched around. Like about 45 to 50% of our traffic is actually Comcast high speed. And that's a big deal. So when Comcast says we're not going to, we're rejecting all of your email, I get a lot of email from students going, hey, I didn't get this email that my password resets were a big thing. So what I ended up doing was we had to purchase an IP address, which Amazon dynamically allocates addresses for these. And that's fine. Most ISPs do that sort of stuff. If you want a set IP address, you have to pay for it. It's not expensive, but they only allow you a certain number of them. So I bought one for Node 1 up there at the top. Node 1 always runs. The other ones may get shut down. I may bring new ones up, but Node 1 always runs. And that actually has what's essentially a static IP address. Then I went into like a 6-week-long process of having Amazon contact all the spam filter people to let them know that this IP address was okay for sending email. Now everything sends email through that gateway. But so that was sort of one thing. Now those 3 nodes, they talk to the big database server, and they also talk to that, and then they also they all talk to that database server. That database server just does databases. It also stores the logs. So I have, because those nodes are ephemeral, essentially, I wanted to make sure I was capturing all my logging. So all of my logs actually get written to the file system on that server also. And then it all gets backed up. And then the other server on the bottom there beneath the MySQL server, that's actually running another web server called Lighty, which is set up to serve up the static files associated with Drupal. Any web server, it turns out, has a lot of static, it serves up a lot of static files. You can think of it, the pictures, JavaScript, style sheets, that stuff never really changes. So what happens is that a request for that actually gets passed by each node back to that server and then served back up through the load balancer back to the client. And it's sort of counterintuitive, right? It looks like you're adding like an extra step to the whole process. But in reality is it actually performs faster. Because Apache will hand stuff off to that server that's optimized for serving up static files. And it just performs faster. And so the whole handoff is quicker than Apache going and looking for the file on the local file system. I know it sounds weird, but I've actually seen it work. And then also, because of the structure of Drupal needs to have like some shared file space. If you have, Drupal has like file space that where you can, people can upload stuff. It also writes temporary files, that sort of stuff. So I'm sharing that with NFS between the three nodes so that I don't have that problem of trying to keep track of sessions and all that, because all that stuff gets written into NFS. Also, faculty can publish lessons using CALI Author. And those always have to be available, and obviously they would need to be in that shared space also. The shared space also covers our lessons, by the way. So that all sort of works together. This is like my favorite slide, my favorite picture of like all time, because this is when I brought the most recent cluster online, which was back in February. You can see that we started to get these really big spikes. The blue line at the top is the Apache server. The yellow line in the middle is the database server. And the red line at the bottom is the Lighty server that's serving up static files. Okay? One of the cool things about serving up those static files, because all it's doing is handing out files, that thing can hand out like, I don't know how many thousands of files a minute, and it never, you get those little bumps in the line, but it never really, it's amazing. But so you'll see that the Apache and MySQL were starting to get above, Apache was starting to close in on regularly spiking over 60%, and that's CPU utilization, so that's sort of the, how much of the processor's getting used. And even though you look at it and you go, well, 60%, well, that means 40% is still free. Well, yeah, but it also means that 60% is being used and things actually slow down. And then that was causing the database to sort of start to get a lot of utilization too, because they interact together pretty tightly, even though they're on separate servers. So I watched this, and 60% is my threshold for throwing stuff at it. I set stuff up on the 24th and 25th, and then the 26th, when I brought them online, you can see a green line and sort of a brown line that come up there late in the day on the 25th. That marks the point in time when those extra nodes came on, 2 and 3, behind the load balancer. And you'll see that immediately the traffic dropped off in terms of CPU utilization and the utilization of CPUs on the database. It just dropped right off. Now, the amount of traffic we were getting was still going up overall. But because the load was spread, it was balanced across these servers, it actually made everything sort of perform better. And that's a pretty, pretty dramatic visualization of that. So in terms of what we actually have running in the, how we sort of take care of all of this. I manage the Amazon stuff through Amazon's web console for EC2. And you can see I took this this morning. We have 8 servers running. So I have a few that aren't inside that, or that aren't part of that cluster. There is the server that powers Technoids. I have another server that we use for development that has a copy of the code on it that that we can. So we don't actually we don't monkey with the code on the live site. So we don't sort of wake up one day and go, it needs to be blue, and just sort of dive in. I mean, there's Elmer yells when people do things like that. We try and work through some code version control and stuff, and a lot of testing. I'm running one load balancer. Those 12 EBS volumes. One of the things about those Elastic Block Store, it's like carving out a hard drive for yourself, and they're persistent. One of the things about those servers is when you turn them off, all the data on them disappears. So if all the data on them is like your database, if it goes down or if it gets shut off, if I click the wrong button, then that database disappears. Now, if you've been backing it up, that's good. But basically, I don't use any volatile storage on those instances. All the volatile storage stuff is on those EBS volumes, and those persist. So I can connect them and disconnect them from server instances. So one of the things that happens, for example, when I bring up when I want to add more nodes behind the load balancer, I'll go back to the EBS volume that's attached to node 1, which has all of the current code for everything that we're doing sitting on it, and I'll make a copy of it. And then then when I start the new nodes, that gets attached to the new nodes. So they come right up with all of the current code, like ready to go at that point. And then we do a little bit. I'll talk about how we also sync them up with our sync. Okay, was that scores? Anything else? Yeah, sure you were.
What's the score?
What's the score?
Let's try to get Switzerland for you.
It's okay. It's a big deal. Somebody was yesterday at lunch. Somebody was sitting there, and all of a sudden, this person just squeaking. So we're like, "Are you okay?" And she was like, "Oh," she took her headphones off. And she's like, "Oh, World Cup." So her team had just scored, and she's so it was great. It's okay. The other thing that you can do is so the EBS volumes is sort of the live stuff. The snapshots are actually the copies that they can make, so you can store those separately. And it also has the security groups, which I haven't really talked about, are actually like firewalls. So I can, only have certain ports open, so that the machines aren't fully accessible to the outside world. And one of the things is that like some of the connections only happen inside of, kind of behind the load balancer. And one of the cool things is that if you have all of your Amazon instances in the same, they have different regions. If they're all in the same region, any data transfer between instances isn't charged, so it's free. So you can build these little sort of clusters, and all the data that moves back and forth between them doesn't cost you anything. All the other data transfer does. Somebody can ask me about how much this costs, in case I forget. So that's that. The other thing is that with NFS, so we use NFS to share stuff between between those nodes and a central spot, and that gives us the ability to sort of have that data in one spot. You know, right now we're using NFS. The NFS shares only accessible inside of the cloud, so they only there's no public internet-facing interface for them, which makes them like this much more secure than, you know. And because they're in the same region, the performance is really good. As we scale up on projects where we're going to have like a lot more data that we need to share, for example, the eLang projects and the Legal Education Commons, where we anticipate having more people, you know, contributing data to the site and using those NFS, that shared data space, more. I anticipate that we'll shift to something a little bit more robust. There are a couple of sort of cluster-oriented file sharing or file systems out there that people with much larger Drupal sites than we have used to do that distributed file stuff. Yes?
I have a question in regards to the way that you have your architecture set up on the back end. Yeah. Now, does Amazon help you segregate the traffic? They're using private IP addresses, I'm assuming, for the stuff that doesn't need to be publicly available. Right. Are they segregating the traffic at all via firewall, or are you responsible for all of that traffic, traffic management? So I'm saying, suppose I have my own install, and it happens to be in the same region as you.
Right.
Do I see your boxes?
No, you do not. You do not see my boxes. So that traffic, because they do that so that because I remember looking this up, and they do have it segmented so that on the private interface stuff, on the private interface side of stuff, you control who has access to those interfaces. So basically, I have them set up so that only my other machines have access to that stuff. In theory, and I don't know if anybody's doing this, in theory, you should be able to open up those interfaces, though, if you wanted to. Like if I had the certificates and I knew what private IP addresses you had, I could open those. We could, and we agreed we could open those interfaces between our machines. But generally, those interfaces are protected so that they're not generally accessible even from inside the cloud.
I think they have a video conversion set up where you can upload a video or even provide them an S3 account, and they'll pull it right from there, do whatever they do with it and send it right back or put it into a new S3 bucket for you.
Yeah, and S3 actually has those kinds of interface controls, right? I can share it. I can share stuff that's in S3 with like nobody. I can share it with specific people. I can share it with the world. So, and this is set up along some of those same lines. The other thing that I mentioned is that I write all of the. I use a program called syslog-ng to actually write all the system logs back to a single server, where I recently forgot kind of about them, and they filled up one of those EBS things and caused some problems. But I fixed that, and it's one of those things, right? On the very bottom of the list of setting all this up is like, write a little script to like zip these up, or and get them out of the way. Well, I got down, and there was that last thing, and it was the end of the day. I was like, I'll get that, later. Then I didn't. But now it does. And then we also have this is how we sync up the information between the nodes, because when a node comes online, it's got that initial data store that's the same, but then stuff changes on AWS 01 is that node 1, of the cluster, and when I push code out from out of development to release into production, it goes to AWS 01, which is the first node, and then rsync runs on the other nodes every minute. I just let it run, even though the changes don't happen that often. I just let it run because there's no data cost to it. And it basically backs up, or it doesn't back up. It syncs the 3 machines from that server, however many nodes there are from that initial master node. Stuff does change under, stuff changes more often under lessons, the third line here, because we actually, whenever new lessons get published, which happens maybe once a month, that data then gets replicated. And this runs once a minute, or runs every minute, I should say, so that when stuff gets put up there, it gets replicated pretty quick. You'll notice that, like, the first line is commented out, because if you actually run that, it causes havoc. I found that out once. I left it there as a reminder that it don't do that. I should actually have a comment that says don't do that. The other thing about with developing in the cloud, because of having all those nodes and stuff, I mean, we had done sort of segregated development for a while. Even with the old system, we used CVS to manage our code, and we had a development server. And then when it was, when everything was working, it was put into production, and we didn't make direct changes on the production server. So when we went to Drupal and moved stuff to the cloud, I started using a program called Track, along with version control, SVN or subversion, to actually manage the code. And what Track does is Track provides sort of a front-end tool for SVN, but also provides you with stuff like wikis and the ability to submit problem tickets and stuff, so that we can, as we're sort of working through code that's in testing. Because the way that this is a shot of the actual code, and you can see that stuff gets, like, I did a trunk is what's in development. So you can see that a week ago I did a bunch of upgrades so I could clean everything up so it was nice and shiny for the conference. So that my Drupal wasn't popping up those little red things that say, you've got a security gap the size of like a large truck that you need to patch. So that's the code, and the way that we handle that development with Drupal is you can actually see. I actually have Drupal under version control. So that if any when changes happen, we update it that way. But what we do is we have the development branch, which is where all of the all the work. Cause we write some modules for Drupal. So this work gets done there, and then that code's checked out onto a development server for testing. The development server, as I explained to someone last night, is somewhat of a mess because we're like always adding stuff to it, and and who knows? Occasionally I go in and clean it up. That's fine. But it's not really. It's intended to sort of be like a sandbox. So once you've got something working on development, it gets checked into the SVN tree, gets committed under development, and then it gets merged into trunk, where we look at it on a beta server, which is an exact copy of the running code on the production server, so that if there's anything wrong or doesn't work, it fails there as opposed to when it hits production. And then after we've looked at it on the beta server to make sure that that's working, gets committed to trunk, and then the production server gets updated from trunk, and then SV, and then the rsync stuff runs to update the rest of the nodes, and ta-da, new features appear. And sometimes that can happen pretty quickly, like in an hour, if it's like a little thing, because I'll just, sometimes, because I had a couple of, somebody found a, well, it wasn't a bug, let's call it a missing feature in the, was it in Lesson Link? Oh yeah, right, in the Lesson Link, there's a feature on the site called Lesson Link that lets you create custom URLs for lessons that faculty can then track. So that when the student follows that lesson link and the faculty, and then saves the score, the faculty can see A, that the student did the lesson, and B, what they did, how they did on it, so they can see their score. Well, I don't have, the code doesn't keep track of time very well, so somebody emailed me and said, hey, I want to do lesson links for the fall, but you only have summer 2010. There's no fall 2010 available. You're not going to take this feature away, are you? So I emailed back and I said, yes, this is coming to end of life now. No, so please don't do that. No, I didn't do that. No, what I did was I just popped open the code and changed the array to add in the fall of 2010 and the rest of those dates. And then I sort of just pushed that right through. But I did go through the whole process. I tested on development to make sure it wasn't going to break anything weird, and then that was working, and then went to beta and fixed it and cleaned up a couple other spelling issues along the way that nobody caught, luckily. And then got into production, and that whole span was just, it was just a little over an hour. But on bigger stuff, where I actually I'll have people look at it. And so sometimes stuff might sit on development or might sit on beta for a couple of weeks or a couple of months while we're working on it before it makes its way to production. Sometimes it never makes its way to production because you get it and it's like, yeah, this is okay. Yes.
Can I ask an SVN question?
Sure.
What was the path again from the development environment to beta to onward? I thought I heard you say you merged it into the trunk and then you committed it to the trunk from.
Yeah. What actually no, it doesn't get it gets because like what happens is this is about to get really technical. What happens is the it gets committed to the development branch. Then it's checked out of the development branch onto the development server. When that's when we're happy with that, then we go to the beta server, and we actually do a merge of those changes from
onto the beta working copy.
Yeah, onto the beta working copy,
which is
and
what
then it gets committed to trunk.
Okay.
Yes, yes, yeah, there you go. And then that gets committed to trunk when it's going. Yes. And that's how. Right. So it's actually technically not in trunk until it's been tested on beta. So that beta just has a really clean, it's running exactly the same modules with exactly the same configuration as the production server.
Wait, so you're saying that when you commit to production, that commit is now live in production?
No, it's not live until I update production.
Okay.
Production is running what's effectively a working copy of the code. Yeah. So I could go in and make changes in production and commit them back, but that would cause people to get slapped in the head and stuff, and they get caught doing things like that. So, and I get email, by the way, every time there's a change, or every time there's a commit anywhere in the tree. So, and actually several people get email. Just so.
One more question. Sure. In your production machine, are you anyway cloaking the SVN files by using some HT access or anything like that? Because will it still dump? I think it might still dump some of that stuff on there.
Yeah, I forget that. Yeah, Drupal does a really. There's stuff in the I think in settings.php or maybe in .ht access somewhere. I know it's there. Yes, they're cloaked so they're not available to. They shouldn't be available. Go ahead, somebody look. You know. But they shouldn't be available to the outside world.
Is load balancer included with EC2, like for free? Or
No, load balancer is an extra cost. And that's a nice signal. Yeah, but the cost is actually, the cost of load balancer is, like, I think it's running me about $10 or $12 a month, something like that. Right now, we're paying about, well, our biggest bill, like, when things got really busy last fall, we cracked like $700 for a month. Right now it's down. It runs between $500 and $600. It sort of fluctuates a month. So that's not cheap, but it's also not real expensive either, considering what I've got, right? So it works out, I think, pretty well. And looking at the reports, because I get these nice detailed bills, they're funny because I get billed for the charge is like per hour for running the servers, for example, and I use a feature called reserved instances, which essentially lets me buy a certain number of server instances and pay a price for them ahead of time, and then I pay like about a third the price on the hourly price, but you actually end up saving about a third overall when you figure out all the costs over the course of a year. But it's funny because all the data transfer charges are most of them run on the gigabyte scale, right? So a lot of the data transfer things, my data transfer costs are 10 or 12 cents a month. Because I don't actually transfer a lot of data. I mean, there's a lot of traffic, but the data tends to, a lot of it's like tiny little images or, different things. We're not streaming a lot of video. So the data charges are actually small. The big charges are really for running those instances.
And for the load balancer, can you go between Amazon regions, or are you stuck in Virginia?
I do not know, to tell you the truth. Because I've been happy with sort of sticking. I feel like I just want to have everything in one place right now. But one thing that might happen as we sort of branch out is we'll probably be looking at things like that. Because the way that Amazon does this is they have data centers in different places, and so you can actually pick where you want your instances to live. There's a place in Virginia. There's one out on the West Coast someplace. I think that's where it is. There's one in Singapore. There's one in Ireland. I think they just opened. There's a few of them around, and typically the charges for talking between those data centers are higher. And also, if you have one of those electronic or elastic block storage things, they can only be attached to servers in the same region. So I've just kept everything in one region. I think. Just seems easier. Anybody else?
Did you look at any other vendors besides Amazon?
Not really. Most of the other vendors. I mean, I did sort of, but nobody really had the. It's one of those deals where I didn't want just sort of the standard, sort of dedicated hosting kind of thing, and they're also more expensive. I mean, the cost of doing something like this on, for example, on GoDaddy, would just be crazy. Yes.
Can you estimate how much labor hours, in addition to maybe doing the same thing on your own, boxes in your own office, how much more of your time did it take to set all this up?
I don't think it took any more or less of my time. I mean, the thing is, I think that's actually a wash. I mean, aside from like having to spend the time unboxing stuff and maybe screwing in some hard drives and stuff, I mean, I think that otherwise it's exactly like running a server. I mean, you sort of flip a virtual switch, and then it comes up, and you do all the configuration things you do for a new server, and then you have to administer it as a new server, and it's just like a server. I mean, there's no, I don't think there's any sort of labor saving here, but I don't think it costs more in labor to deal with either. At a certain level, I don't worry about it as much. We had issues. Emory has network issues on occasion. So when our server was, when we were running our main stuff out of Emory, there were a couple of times when Emory had network, campus-wide outages during exam season, right? And their connection to the internet would be down for one day. They were down for like 6 hours. And and when something like that happens, I'm really powerless because I'm sort of freeloading anyway. And so I just have to sit there and wait for the power to come back on, essentially. So this actually gives me a little bit more security. I don't worry about it as much.
And then in terms of cost, how much computing power did you buy for $500 to $700 a month?
What I've got is, that's a really good question. I forget exactly what the details are. The Amazon, I'm running, the database is on one large instance, which, if I remember right, let me see if I'm still. The database is running on one large instance, which I forget is like the equivalent of like a dual processor, dual core server, and the Apache nodes are running on small instances, which are like the equivalent of I think dual core single processor servers that have, I think the small ones might have 4 or 6 gig of memory and some internal stuff. One of the things is it's kind of a floating target. It's always going up. Periodically, every quarter I'll get a message saying, "Hi, your small instances are now this much bigger." Okay, because they're sort of at a point, and then as the technology comes in, it's probably the web nodes would probably be the equivalent of sort of the standard Dell, 1U, dual core, maybe quad core, one processor machine that you go and buy for, however much, with a whole bunch of hard drive space on it. It's one of those things where it's almost, it's like having a data center in your pocket kind of thing. And a lot of times, the other thing that's kind of cool about it is, the ability to do, just try something out, right? Because if you've got a chunk of software you want to take for a spin, so to speak. There's an open source conferencing thing that's similar to WebEx called Bluebell or something like that, Blue something. But it uses a whole bunch of stuff, and they've got really nice instructions for how to run it under Ubuntu. And I wanted to try it out. So, I just fired up an Ubuntu instance and then downloaded all the stuff. And a half hour later, I was having a little video conference and screen sharing session with some folks, and I fiddled around with it for a while and made a note that I probably want to come back and look at this again. And I turned it off, and it cost like $2, but and so being able to do that sort of stuff is pretty good too.
How much time do you spend micromanaging the server nodes? So I know not during the school year, you might just kind of get away with just the first node that kind of runs everything. But during exams, are you looking every morning or at last night's logs and turning on nodes depending on how many people are going there, or do you just kind of leave them on when you know you're probably going to get hit?
Yeah, we've been, I've got enough data floating around that I know when I know when stuff is gonna happen. Yeah, so, yeah, and then a lot of times I keep this up and I refresh it about like once an hour. I mean, I could, pay a lot closer attention to it if I wanted to, but frankly, I've got a lot of other stuff to do. I'd love to hire a sysadmin to just take over this part of stuff, and because there's a lot that could be done to like automate this and sort of fine tune it, and everything that I just don't have the time or the skill set as far as that goes for. But yeah, I actually keep an eye on this table a lot, just like I used to watch Top on the, that's kind of like watching Top. And so I just, and there are like companies out there that'll like do this for you and send you alerts. You just have to pay them $100 a month. Yes, that's nice. So but so I don't spend any more time than I would if they were the physical server. Anybody else? Okay. Well, thank you. Now I have to go talk about ClassCast. So if anybody's interested in blogging, that'll be a different kind of session. It's going to be kind of like, just some software demos, and hopefully I'll talk less. Thank you. Steve, how you doing? John Mayer thought he'd be funny and IM me during this session. Like I would have that pop up on my screen.
Doug did.
Well,
On Monday, my boss asked me, what do you know about Drupal? I've been looking through the thing, I'm going to find out Friday.
Yeah. Well, Drupal's
You guys have really moved to one box on the law school network that keeps on, it might go down any time.
Yeah.
Once you guys have a lot more traction than 7 years.
Yeah. Right, I'd forgotten about John forwarded me that. Yeah, John sent me that link that doing something about the Siglinda stuff. And I forgot about that. Yeah, because like you get like that amount of traffic like during December and peak time, like you get that much traffic.
I know. Concerned about is that there's no changes to getting more than some of
Yeah, that's always well, still.
Somebody here.
How is that?
The thing is, like, they run all the lessons, most of the lessons get done on the website. So, You know, but students don't, I mean, they come in there.
Unless it's that's like all the reasons.
Yeah.
But I am now. It wasn't.
I mean, every